Imagine you are building an advanced system for self-driving cars, or perhaps a tool that helps doctors identify abnormalities in medical images. How do you objectively measure if your system is doing a good job finding the objects it is supposed to detect? Intersection over union, or IoU, is a fundamental metric in computer vision that quantifies the overlap between two bounding boxes. It tells us precisely how well a predicted bounding box aligns with a true or ground truth bounding box for an object. It is a critical measure for evaluating the accuracy of object detection models. The power of IoU lies in its elegant simplicity and mathematical rigor. It is calculated by dividing the area of overlap, which we call the intersection, between the two bounding boxes by the area of their combined region, known as the union. So you take the area where they overlap and divide it by the total area they cover together. A higher IoU value, closer to 1, indicates a greater overlap and thus a more accurate detection. Conversely, a value of 0 means no overlap at all. This normalized score is incredibly valuable because it is independent of the absolute size of the objects. Whether you are detecting a tiny ant or a massive truck, IoU provides a consistent and comparable measure of localization accuracy. This robustness makes it indispensable for comparing detections across various scales and ensures that your model is geometrically precise. It moves beyond just saying an object was found to specifying exactly how well it was located. To leverage IoU effectively in your computer vision projects, you typically establish a specific threshold. For instance, if your object detection model predicts a bounding box around a pedestrian, and the IoU between this predicted box and the human-labeled ground truth box is above, let us say, 0.5 or 0.75, that detection is then considered a true positive. If the IoU falls below this predefined threshold, it is usually classified as a false positive, meaning the model detected something that was not truly there or did not locate it accurately enough. This threshold-based approach is fundamental for computing vital performance metrics such as precision, recall, and the F1 score, which collectively describe the overall effectiveness of your object detection system. Beyond its role in evaluation, IoU is also a cornerstone of non-maximum suppression, a crucial post-processing technique in object detection pipelines. When a model predicts multiple overlapping bounding boxes for the same object, non-maximum suppression uses IoU to intelligently filter out redundant detections. It ensures that only the most confident and accurate bounding box for each distinct object remains, significantly cleaning up the output and presenting a single, refined detection. Understanding intersection over union is more than just learning a formula. It is about gaining a powerful tool that empowers you to not only rigorously evaluate your object detection models, but also to understand their geometric performance at a deep level. This insight allows you to fine-tune parameters, optimize architectural choices, and ultimately build more reliable, precise, and robust computer vision applications that can accurately perceive and interpret the world around them.